Welcome back to the lesson. My name is Mr. Wong. Today we're going to be covering two concepts, or revising two concepts. One is writing chemical formulas for ionic compounds, and then our second part is just to do a couple more practice questions on balancing chemical equations. So let's go on to ionic compounds. Now, firstly, ionic compounds is made up of a combination of a metal and a non-metal, so you need both to form an ionic compound. So that's what I mean, ionic compounds, it's a metal plus a non-metal. Okay, that's our starting point here. When it comes to writing out ionic bonds, firstly you need to identify the symbol that you're dealing with. So you must write the chemical symbol first. Always remember that the metal is written first. In this case, it's calcium. And then the non-metal comes second. In this case, chloride. Okay? I'll just change the color. Taking the pen. So here is calcium. And here is chlorine. Okay. The next one we have is work out the ion that will form. So you need to work out the charge number. So what is the charge number? Okay. To work out the charge number, you'll need to look at your periodic table. Remember, the group number will indicate what the charge number will be. Okay, so we find that calcium is 2 plus and chlorine is 1 minus. What you need to do next is the crisscross method. So you make the charges move to the bottom of both sides, and that becomes the subscript. So our subscript here is 2 for chlorine and calcium is 1 subscript, or represents 1 calcium atom. Okay, remember to erase the charge, so remember to get rid of the plus and the minus charge when you do the combinations there. What you should find is this should add up to 0 overall, so we have calcium of plus 2 charge, we have chlorine, 2 chlorines of minus 1 charge. So you can think of it as positive 2 minus negative 2 equals 0. So it should add up to 0 at the end. So adds up to 0. Okay. The next example we're going to go with is writing out ionic formulas, but for polyatomic ions. So polyatomic ions, something like sulfate, is something that's made from multiple atoms. Okay, so that's an example of a polyatomic ion. Firstly, same as always, write out the names, write out the symbols. So aluminium is Al, sulfate is SO4. Now if you do plan on doing higher levels of chemistry in the future, you do have to remember sulfate, nitrate, and all those kind of symbols there. Now, this 4 here, I just want to quickly illustrate, represents that there are 4 oxygens bonded to this 1 sulfur atom. Okay, it does not mean that we have 4 sulfates. This 4 means here, if I want to say there were 4 sulfates, I would write the 4 in front here. But this is what a sulfate looks like. Okay, the next thing we need to do is include the charge number. So aluminium is 3 plus, sulfate is 2 minus. In the questions we are going to do later on, we do give you the charge, so don't worry if you don't know where the charge came from. We are going to now use the crisscross method. So we're going to move the 2 over here, and we're going to move the 3 over here. That leaves us with this formula here. You can see I've actually put brackets around. The reason being is because this 3 here represents I have 3 sulfate ions. Okay, so this is another way of representing how you can have 3 sulfates instead of just writing the number at the front. You can see the 3 from the aluminium has now come down to the 3 here, and the 2 has come down to the 2 here. Okay, the only time you need to put brackets is if the new subscript you're putting in is not 1. Okay, so if the subscript is not equal in charge with whatever you had before, then you need to write down here, and you must draw the brackets. If you don't draw the brackets and I write the 3 next to the 4, it would imply it's 1 sulfur and 43 oxygens, which is not possible. Okay, the last thing you can do is check whether or not this equation, this formula adds up to 0. So if I have 2 aluminiums plus 3 sulfates, aluminium has a charge of 3 plus, so 2 times 3 is 6 plus. And then sulfate, we have 3 of those, and it has a charge number of 2. So 3 times negative 2, we get positive 6 plus negative 6 equals 0. So that's how you do that. So let's look at some questions and apply it again. Okay, so we have the table here. We have our sulfates, our hydroxides, our carbonates, and then we have these cations over here. Okay, now iron is usually 2 plus. If they don't tell you, if you can see here, it's actually 3 here, so we actually can call it iron 3. Okay, so let's have a go at trying to write some formulas. Let's do iron. So we're going to do iron and we're going to do nitrate here. So the chemical we form is iron nitrate. So unlike previous ionic compounds, if you're dealing with polyatomics, so polyatomic ions don't change names. Okay, so we won't expect a name change if we're using these. We do expect a name change with obviously the anions as examples. So iron, and I'll just use a bit more space than necessary just so it really portrays what I'm doing. So iron is 3 plus, nitrate is NO3 minus 1. They're going to crisscross, so it becomes, and I'll change color again, just so you know the difference. Iron, this is minus 1, so it comes down here. I'm not going to write it down because it is a redundant number to write. NO3. Now you can see that this 3 hasn't been used yet. This NO3 is just to represent nitrate. Okay, so you cannot change this number no matter what. It has to be there at the end. So this 3 needs to come down onto this side. That means that I will have 3 nitrates. If I just write the 3 like this, it would imply that I have 33 oxygens. That's not right. So I need a bracket, and that's my formula to show iron 3 nitrate. I might also add, it should be called iron 3 nitrate. Okay, let's use another example. Let's use sodium hydroxide. So our sodium here, our hydroxide group here. So we have sodium hydroxide, sodium is +1, hydroxide is 1 minus. They're going to crisscross, and it's just going to be NaOH. Notice how I haven't written any brackets here because at the end of the day, we only need 1 hydroxide to balance out the sodium. So that kind of explains that. Let's have a look. Let's do sodium again. with sulfide. So we have sodium sulfide. It is Na plus S2 minus. You can see from that value there. So it becomes Na2, because this 2 comes down here, and this one will come down here, which we just write as Na2S. Okay, so that's basically that. And that's how you do those. So try some of these, or actually try and finish all of these, and see what answers you get for those. Let's see if there's anything missing here. No, that looks fine. Alright, so there's that. The second part we have of this lesson is to, do some more practice on balancing chemical equations. Okay, so when it comes to balancing chemical equations, remember the rule: we always try and ensure that we are balancing, we're making sure everything on both sides is equal to each other. Okay, so using the pen, we can see that on this side, and you can always draw out a table to help yourself. On the left hand side I have 1 barium, I have 2 oxygens. On this side I have 1 barium and 1 oxygen. So what I'll need to do is I'll need to change the coefficient at the front. I cannot change the subscript. Okay, coefficient change. Okay, that becomes 2. That means that now it's 2 times 2, 2 times, or 1 times 2, 1 times 2. We have 2 on the 2 sides. And we still only have 1 barium on the left hand side. So I'm going to put a 2 here to make it balanced. Okay, that's the idea here. If we have this kind of scenario here, actually let's use this one over here. So that is supposed to be a little 2. So you can see how we have 1 nitrate group, 1 nitrate group here, 2 nitrate groups over here on the right. We have 1 hydrogen, we have 2 hydrogens. I should probably have that in a different color, shouldn't I? So 2. Okay. We have 1 magnesium and we have 1 magnesium. So the thing that doesn't balance out firstly is the nitrate. So I'm going to put a 2 in front here. That gives me 2 hydrogens, so that equals. And that gives me 2 nitrates. Magnesium's already balanced, so that's it. That's how you do that. Alright, a bit more of a challenge is to actually write the chemical formulas by themselves using the word equation. Okay, so what you'll need to use is the table up here using the ions to work out what the balanced chemical equations are for these following word equations here. So I'll do one and see if you can do the other. So firstly we have lithium, which is lithium is plus, carbonate is 2 minus. So it will become lithium 2, carbonate 3, CO3, like so. We have calcium, which is 2 plus. Chlorine is 1 minus, so if they crisscross, we get calcium 1, chlorine 2. And then when we look at this one here, we have calcium, which is 2 plus, carbonate, which is 2 minus. Now because the numbers are exactly the same as each other, we just add our symbols together. Okay. Next one we have lithium and chloride. If it's lithium, it's +1. Chlorine is 1 minus. So it's just lithium chloride, like so. Okay. So there's that. Alright. If we have a look in the comparison, we have 2 lithiums we only have one. Okay, nothing seems to reappear twice, so we can just chop and choose which one we want. So I'm going to put lithium, a 2 in front of lithium here. So I have 2 lithiums and I have 2 chlorines. I have 2 chlorines here, I have 2 lithiums here. And they have 1 carbonate, I have 1 carbonate, 1 calcium, 1 calcium. So that's it. Equation is balanced. The important part is obviously getting the right formula to start off with. So that does come into account making sure that you have the correct valency charges. And just remember, if an example where the charges are the same, so magnesium 2 plus, and then we have oxygen 2 minus, technically you could write it as Mg2O2, but we try and factor it to the common, or factorize it to the common factor, common numerical, and so we just write it as MgO instead usually. Okay, so that's what you have there. So hopefully you found this video useful in writing ionic formulas and also balancing equations. Hopefully you can keep watching, but anyhow, take care.